All right. So, hey guys, today we are talking about triangle congruence. So what that means is two or more triangles that are exactly the same, proving that they are the same. This is the introduction to proofs. So here we have an example of two triangles, triangle ABC and DEF. We're going to talk about kind of what we see with these two triangles. We already see a side and a side. They have that little hash mark on them. That little hash mark indicates that they are, in fact, congruent. That's what those marks mean. So line BC with one hash mark is congruent to line EF with one hash mark. That just means they're the exact same length. If this was 5 inches, so is this one. If this was 10 inches, so is this one. So then we have line AB with 2 hash marks. So we're going to look over at our other triangle. It's DE, also has 2 hash marks. So those two are, you guessed it, congruent. Line AC and DF both have 3 hash marks. So that means however long this length is the exact same as that one right there. They're indicated with hash marks or actual measurements. Yeah. Not only do we have the little hash marks for the sides, but we have these little angle arcs for our angles. So we have angle B and angle E are the same. Angle C and angle F are also the same. Angle A and angle D, they both have 3 little arcs or 3 little hash marks. They are the same. Congruent triangles, or the same triangle, is literally defined by same sides, same angles. So looking at these, it literally tells us all the sides are the same, all the angles are the same. Boom, triangle A, B, C, and triangle D, E, F are congruent. That's it. We have our sides, we have our proof of congruency. Those two triangles are congruent. We can't argue with that. That is a fact. Then we get triangles that aren't congruent. Looking at these two triangles, mind you, most drawings are going to be fairly accurate, but not always. If they tell you that this is 5 and this is 5, you have to accept that they're both 5, even though they look different. But because there's no measurements and there are no hash marks, we can identify that this triangle has clearly been dilated. This triangle has clearly blown up some, right? We already talked about dilations last unit, shrinking and getting a shape bigger. And we said that was the only non-rigid transformation, because a rigid transformation makes the sides and the angles the same. So anything that goes through a rigid transformation is congruent. Anything that goes through a non-rigid transformation is either non-congruent or similar. So these two triangles are similar, but they're not congruent. And we will talk about similarity next week. So right here, they color-coded it. So angle A and angle E are the same. Even though angle E is part of a bigger triangle, it's still the same size angle. Angle C and angle F are the same, and angle B and angle G are the same measures. So that triangle is not congruent, but it is similar. Triangle congruence, again, triangles that have all the same sides and angles. But we don't need all of that information to prove it. We only need 3 sets of corresponding parts. So we can have 2 angles and a side. We can have 3 sides. We can have an angle and 2 sides. We can have kind of a mix. And we're going to learn that which mix proves beyond a shadow of a doubt that those triangles are the same. There are 4 ones that we will learn that you actually use pretty often. And there's kind of a little extra bonus one that only works for special triangles, but it's pretty easy. But it's not letting me. Here we go. our first set of 3 corresponding parts is angle, angle, side, or AAS, angle, angle, side. That is when they give you 2 triangles and you have those parts given congruency in that order. So here we have an angle that is the same as this angle. We have another angle that is the same as this angle. And then we have side that is the same as this side. So when I look at these, yes, they're in the same like they're coordinating spots, even though that triangle is turned, they're in the same spots. I'm gonna look at it and I'm gonna go, we have an angle, and a side. So those 2 triangles are congruent because of the angle, angle, side theorem, or we can prove that they are congruent because they fit this definition. The actual definition is 2 angles and a side that's not between them are congruent. So we can say triangle JKL is congruent to triangle YXW because angle J is the same as Y, L is the same as W, K must be the same as X. We know it's the same as X because we've said those 2 triangles are the same. That's really the hardest part. That's it. This is the hardest one. We started with the hardest one. Just because it's not the one that pops out the easiest, but yeah. So that is any 2 triangles that have 2 congruent angles and that third that third corresponding part, the side, that is not in between them is angle, angle, side. It's as hard as it gets. So next right here, we have our next one. We have side, angle, side, which means you have a side that's marked congruent next to an angle next to a side in that order. Side, angle, side. So it's like an angle sandwich. We have a side, an angle, and a side. If 2 triangles have those same parts, they are congruent because of the side, angle, side theorem, or postulate, whatever it is, because of side, angle, side. So here, triangle LMN is congruent to triangle PRQ because L corresponds to P, M corresponds to R, N to Q. Those 2 triangles are congruent because of the side, angle, side theorem, which is 2 sides of the angle between them, or 2 sides and an angle between them. So when you see an angle or a side sandwiched between 2 angles on 2 different triangles that are given the same data, same information, they are congruent. I know this is tough stuff, y'all. Our next one is angle, side, angle. So it's the exact opposite of side, angle, side. So this one is a side sandwiched between 2 angles. This one shows us we have congruent angles, followed by a congruent side, followed by a congruent angle in that consecutive order. Angle, side, angle. Have to be up together like that. If you have those corresponding parts on 2 triangles, those triangles, you guessed it, are congruent. You only need those 3 pieces to prove that these triangles are congruent. Those 3 parts could not make 2 different triangles. So, like we'd mentioned before, FGH is congruent to UVT because you have to follow the same order when you state congruency. F is the same as U, G is the same as V, H is the same as T. You have to make sure you get those parts right. That's what my last class struggled with the most, getting them in the correct order. So we have AAS, which is the hardest one to find, in my opinion. Side, angle, side, which is an angle sandwich. Oops. Angle, side, angle, which is like a side sandwiched in between 2 angles. And almost last but not least, side, 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 which is exactly what it sounds like. If the 3 sides are congruent, the triangles are congruent. You can't take 3 different sides of a triangle, or 3 of the same sides of a triangle, and you can't create another triangle. It might be flipped upside down, it might be mirrored, it might be slid over to the side, whatever, but it's going to be the exact same triangle every time. Sorry, that was my apartment complex trying to call me when they should be calling my brother because he's the one that's home right now. My sink, or my kitchen flooded the other night, so yeah, that's what I'm dealing with. Anyway, so side, 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 get back to that. That means you're given 3 sides on 2 different triangles. They're the same. If this is 3, 4, and 5, this is also 3, 4, and 5 every time. We can state beyond a shadow of a doubt that those 2 triangles are, you guessed it, congruent. ABC is the same as XYZ because angle A is the same as angle X. Line AB is the same as line XY. Line BC is the same as line YZ. You got to be careful about the order. But all 3 corresponding sides of the 2 triangles are congruent. I know, it is quite mind-blowing. We have one last thing, which is hypotenuse leg. Only right triangles have a hypotenuse. So knowing that they're right triangles kind of limits its ability to, like, it kind of sets it up for this extra thing where you only have 2 additional parts, but you also have the 90-degree angle. So here we have side, side angle. Please read it in that direction. Side, side angle, which only proves congruency with a right triangle. So we have hypotenuse the leg. They change it up a little bit to make it fancy. We have hypotenuse leg, where we have a 90-degree angle, the hypotenuse, which is that long side opposite the right angle, and a leg, which is the short legs, the short sides. If you have 2 90-degree angles where the hypotenuse is the same and the leg is the same, well, both of those 90 degrees are the same as well. But then you have the hypotenuse leg congruency theory, where those 2 triangles have to be the same. That's all we got today. That's the main part of what I want you guys to grasp this week. So note that side, side angle and angle, angle, angle do not prove that 2 triangles are congruent. If you see that, those triangles, we cannot say they are congruent without additional information. They can show similarity, but they cannot show, they will not be a congruency proof. They will not show that those 2 triangles are the same.